All right, so as some of you know, yesterday we had a little trouble with the stereo with CalVR, so we were behind, so we decided to skip it for today. So last night I spent a couple hours working to debug CalVR for them and fix their stereo, but I failed. So in the spirit of that last animation, we will be doing this glasses free, and it'll look natural to us, more or less. All right, so yeah, Simon. Correct. And I knew that because all the other apps stereo was working fine. It was just CalVR that stereo wasn't working for. And it has some really weird thing. Well, so I'm in conversation with him, right? So, well, this is the weird thing. I believe that Monday night it worked. But now I can't prove that, so I don't know. Right? So the people who wrote CalVR, well, I got a little intro then. Who wrote CalVR mostly don't use quad buffer stereo. As a matter of fact, they pretty much don't use quad buffer stereo, and so they don't know that the quad buffer stereo doesn't work. Well, they do now, but they didn't before. They use either like, you split it left and right and let the TV divide it, that kind of thing, or two projectors overlaying it with filters. So they do those kind of stereo setups. They haven't done any quad buffer stereo setups, so they didn't know it didn't work. And well, let me just get started with talking. Oops. All right. So CalVR is relatively new to all the other VR libraries we've been discussing, and just begun, I guess, almost 3 years ago. And the question I ask when I hear somebody's writing their own new VR library is, why? Why are you writing a new VR library? We have enough of them, I think. There's a fair amount of diversity among the existing ones that you would think that you could find one that kind of suited your needs. Well, they gave me what I think is a reasonable explanation, and that is they were using a program or a system called CoVise from the Supercomputer Center in Stuttgart, Germany. And CoVise, like many VR libraries, and actually it's broader, it's a little bit broader than VR, but like many systems of its type, it kind of spreads through the migration of the users. So some people from Stuttgart went to Brown University, and they brought CoVise with them, and then they went on to Cal IT Squared and brought CoVise with them. And so they were using this kind of as their CoVise as their framework. But they decided that CoVise, because it's more than a VR library, it was a little more than what they wanted. It was too complex, it was hard to maintain. So they decided to write a library that basically would allow them to port their VR apps that only use the VR part of CoVise to something that was a lot more trim and that they could maintain themselves. And so that is why they wrote their own library. All right, so the motivation slide here is, so most of our talks have been about applications, not about libraries, although I did talk a little bit about VRUI. This one's kind of mixed. So the application we're going to kind of talk about is this archaeology application that combines point cloud data, artifact dig coordinates. You can also have meshes, which are generally created from the point cloud data, and photographs, things like that. I don't know if there's any photographs in this one, but let's see. And now we're going back to CalVR. So some of the CalVR features are that it works in clusters. Most of the VR systems that Cal IT was doing, had like 20 displays, and so they would have, about 6 or 7 computers feeding those displays, so they needed cluster capabilities. It's entirely built on OpenSceneGraph. They let OpenSceneGraph handle a lot of the graphics, underlying graphics things, and this is where, so they were anticipating that OpenSceneGraph would do quad buffer stereo the way OpenSceneGraph does all the other kinds of stereo. But OpenSceneGraph, if you're doing quad buffer stereo, you have to tell it when you want to render to the left eye buffer and when you want to render to the right eye buffer, and they were unaware of this fact. So that's why stereo is not functioning right now so it's primary Linux. They also have it on OS X, and they report that it also works on MS Windows, but not 100%, like not the clustering and things like that. It's entirely, it's like its own little world. So it's like, you have your phone operating system where the phone operating system controls everything, and you can load in apps, and you can start an app and stop an app. So it kind of works on that methodology. And so here's kind of the main menu here. When you start it up, you get some controls at the top that are standard, so how to navigate through the world, how to control eye separation and head tracking. And then everything below the eye separation, these are all sort of plugins. Now, you don't plug them in live while you're running the program. You actually have to have a configuration file that says which plugins you want loaded, and it has to say which data sets you want affiliated with those plugins. And you can have multiple data sets and choose them as you load them in, but it's all sort of, even though they're plugins, they're all pre-configured. The configuration file itself is XML based. They have two types of inputs, TrackD and VRPN, and mouse as well. It has this built-in navigation features. You get this choice of 5 to start with. And yes, Dave.
What lab did this come out, or is this
Cal IT Squared, the Larry Smarr's new, somewhat new group at UC San Diego. So it's under Tom Defani, all this effort. So there is some overlap to plugins that, so CalVR is fairly new to me, so, but what I've discovered is that, yes, so like there's a panorama viewer, and there's this points with panos plugin, and the points with panos plugin requires that the points plugin be loaded ahead of it inside the configuration file. So there is some overlap. And then like this Artifact 2 viz, I think probably just shares some code, because it also loads in point clouds as well, and images and things like that. But I don't know how much they just sort of took the code and copied it into the new plugin directory versus have it more modular where they kind of do that. I haven't explored it enough to know that. We're not going to look at it today, but there is a calibration mode. I think the button is probably on here somewhere. No, it's not. Oh yeah, there it is. So that's a plugin, collaboration. We're also not going to do multi-user support today, but they have some very experimental methods for having more than one user. So you have two users both being tracked, and they have different displays where they'll do different techniques, some of which if you have one person looking here and one person looking here, it gives them their own proper stereo, and then it kind of blends the stereo between them, and then as they sort of look in the same spot, it kind of does an average between the two people. So neither one of them really gets the proper perspective, but they're doing a little research along those lines. They also have some auto stereo displays that have 8 different channels versus the kind of the lower end, which will only have 2 channels, and they have rendering modes built in that'll handle that. They do so a lot of stereo techniques kind of interrupt the graphics, right? So like the passive stereo displays that we have over there, the way they work passively is that every other line is for each eye. So every other line is for the left eye, and then the alternate lines are for the right eye. And so if you turn on anti-aliasing, you're blending between eyes, and you don't want that. So they have some code that will counter that and let you do anti-aliasing without messing up the stereo. And then the Omni Stereo is part of this multi-user support where you can have multiple people being tracked. Oh, no, actually, no, I take that back. So Omni Stereo is where it basically, someone's being tracked, but the stereo always assumes you're looking straight at the screen. So it's more for this kind of a setting where people would have their stereo glasses, and if I'm around with the tracked glasses, I mean, one of the reasons we have Harry here is that if I were in a normal application face you, now the stereo becomes reversed if a face becomes messed up. So they have a method where basically the stereo ignores the head tracking. The head tracking still operates, so you can walk around things, but but the stereo ignores it. All right. So here's some of the plugins that they have, most of which I've compiled. I don't have OSG Earth compiled, but these are pretty simpler ones at the beginning. The image viewer, you just loads an image. You can have some images floating around. The model loader, you can load basically any model Open Scene Graph can do. And so I'll bring up one of those just to get us started. You can load point cloud data, so kind of like Lidar Viewer. And then there's this little sketching program, and I'll do a little bit of that. And then Artifact 2 Viz, or Artifact Viz 2, we'll look at in a slightly more detail. All right, so the choice of VR library is back to why did Artifact 2 Viz choose CalVR? Well, the KAUST visualization group basically was seeded from the group at Cal IT2. The guy directing the visualization group there came from UC San Diego and then subcontracted back to UC San Diego for support. And so basically CalVR is part of that support. All right. All right, and so let's do some live demonstration. I was almost going to use this as my wand. All right, so I can actually, one of the things I can actually do is turn off head tracking if I remember which button to push. There we go. And so I don't even need to walk around. We'll move that over here. All right, so the first thing I'm just going to do is look at some of the navigation techniques. Just want to keep track of time here. I don't want to overblow this. Oh. So we'll just do a quick tour of the navigation techniques. So I have this little Cessna plane. There it is. It's down there. It comes in rather small. If I do a view all, it'll kind of scale it to the world, kind of like what Oliver does. And then this has a navigation technique that I kind of like, but is not very common. It's not really familiar to people who are used to desktop interfaces, and that is when I press the trigger, this wand now becomes a joystick relative to that wherever the wand was when I press the trigger. So if I push forward, it's like pushing a joystick forward. If I pull backwards, by going backwards. If I go down and up, it's like kind of like a little rubber band thing. And as I rotate, the rotation also is relative to where I press the button. Now you'll notice it's only going around its up axis, the Z axis. It's not doing anything else, and that's because it's in drive mode. If I put this in fly mode, now I can do anything. We can pretend like we're flying a little airplane here. Yes, I'm holding the button down. So when I let go of the button, it will stop. When I press the button, I now create a new reference point. So if I'm over here, and I go this way, the airplane will go that way. Oh, we're crashing. All right. So, and then you can have multiple things. So let me just load an image just to. So the image viewer is actually a little bit different in that. So I meant these are stereo pictures, but since stereo doesn't work, you don't get to see it. It keeps everything in the plane, except when I move up and down, it actually goes in and out a little bit. And so we can have multiple images here. There we go. And the airplane, though, has a different navigation style. All right, so that's that. Let's remove our images. I'll move our model. And I'm going to load one of the panos. I think I use it here. Unfortunately, I don't want that yet. Go. Oh, sorry, Dave.
Could you just load in like multiple copies of that plane?
Yeah. Oh no.
Or will they
Well,
on top of each other? Or?
That's a good question. Let me. Oh, there we go. Yeah. Oh, let me turn on head tracking here. We will try that in a moment.
Trying to make it blow up.
Yeah. Well, yeah, that may easily. All right, so here's a Lidar data set. So I didn't get the panoram, but here's sort of a Lidar data set. Oh, I'm on fly mode again. Let me reset that. And you can see we're kind of stressing the system here a little bit. And so for point of comparison, I put these Lidar data sets into Lidar Viewer, and you'll see that Lidar Viewer does. I'll run it, and you'll see that Lidar Viewer actually does a much better job at this. All right, so there's the data set. Let me go into drive mode so it doesn't rotate on us. Now, not that that's not necessarily CalVR's fault. That's the plug-in to CalVR. Oh, there we go. It's better lighting up here too. And we can scale the navigation to make it relative to our thing, and it kind of goes in a logarithmic thing. So as I move further away. All right. So this is one of the data sets from the archaeology application. And so one of the things you're seeing is something I discovered, that the lighting is kind of weird depending on your point of view with it. And the slow frame rate is a little painful. All right, so I'm going to remove that. Oh, things sped up a lot there. Before we get to Artifact Viz, I want to bring up the panel view. And I'm going to do the temple. All right, so you see it's loading the data. It's going to take a little time. So these are actually stereo panorams, or at least most of them are. Still loading data. There we go. So these are photographs that Tom DeFani took when he was visiting Luxor. I guess I can set this down. All right, and so in the basic mode is we can just use the joystick to kind of rotate around once it catches up here. I think it'll cache it and it'll speed up a little bit. Now there's also a sub-menu with this plugin, which I think is somewhat unique for the more complex plugins. Let me see if I can summon that. Oops. The frame rate makes it. There we go. Oops, very far away. Ah. All right, well, I'll tell. Huh?
Maybe create another slide based on watching that.
Yeah, yeah, exactly, right. So what this does is it actually lets you control it where you can tilt it, so it's not limited to sort of standard horizontal mode, and it has some other features for how you can go into demo mode and automatically rotate, but you can. It is far too painful to. I'm going to use the mouse actually to. So it interfaces with the mouse as well. So I'm going to bring up the main menu with the mouse, I hope. There we go, and we're going to remove. There we go. All right, and now we'll try what Dave asked, and then we'll move on to the main application. Well, we're still slow. Is there still LiDAR data? Aha, all right. Well, that's probably why the panel was slow then, because it was much slower than I was used to. That's still slow. I'm going to just restart it. No point in unnecessary suffering. All right. All right. All right, much better. All right, so we'll try what you asked, Dave. Let's load a Cessna. The pumpkin file actually isn't there, so well, let me do that. Yeah, all right. I did. There we go. We got two Cessnas now. All right.
But maybe the interactions are you would need some sort of other plugin to manipulate. If you wanted to even do something like move the individual models. It seems like a lot of these navigational techniques
Right.
flying around the world.
It basically, yes, that's correct. And so it is more of a scientific visualization tool. Although they do have some where you kind of fly around buildings and stuff, but still you pretty much use the same navigation technique. So it's more like the building is your data set, not you're trying to physically mimic the walking of inside a building. All right, let's move our. I get them? All right. So now let's do the Artifact 2 viz real quick here. So it allows you to wait to turn it on. And then it comes up with its own little submenu. And so let me load one of the point clouds. Oh, I was going to do sketch too, but that's all right. Sketch is just, paint stuff and create little boxes and things like that. All right, so here's a fairly nice Lidar data set of, let me get this menu out of the way. Of an archaeological dig. Like I say, I put this in Lidar Viewer as well, so this is actually not too bad. So there must have been something else that had consumed memory and was dragging us down. So here you can see they've excavated down into the earth. They found some walls and things. And so one of the things beyond than being a point cloud viewer is we can actually load in some other things. So there's some sort of virtual reference things, like where the walls, where they've determined maybe some walls are for this for a particular building. Let me put the glasses on here. This won't mess up your stereo. Actually, it messes up mine more than yours. So here, where they've put some, of their analyses overlaid on top of the actual data, and then we can load in some artifacts where they found artifacts. And it gives me a little, oops, I didn't want that. I want artifacts, not file manager, artifacts. All right, and so these are collections of artifacts. Oops. So the one though, I think only has one artifact. Let's see. There it is there. So here we've just loaded in this first artifact, and I'll fly over to it. All right, and some of them have kind of little models to show what the artifact looked like, and other ones just have little symbolic representations for whether they were money or pottery. And so here, if I remember which button to push, no, wrong button. Perhaps the right button. Yeah, that's right. Well, I'll tell you what I'm anticipating happening. It'll bring up this little data sheet that describes where it was, its exact location where it was found, some descriptive information about it, its artifact number. It looks like it may have been a very wrong button. All right. Well, I'm not going to be too patient here.
How hard LiDAR is. Because like the movie LiDAR really things.
Right. Now, so this one's not loading things in and out, so things don't jump around on you and stuff. Well, maybe I'm really the wrong button. All right. All right.
I wonder if it needs more, mixing these different types of data.
Right. Right, that it doesn't clean up very well afterwards, yeah. All right, so I just want to quickly show the more than one artifact and how it kind of overlays with the LiDAR. So let me bring up maybe bring up the artifacts first. All right, now we got to find them. Let's get rid of this. Oh, there they are. All right, so fly over there. All right, so we'll look at the artifacts without the LiDAR data first. So you can see some of them have little models. Oh, there I got one by accident. And so here's a little descriptive panel that comes up, which overshoots its box a little bit. And I asked him what the jitter was. Basically, these are all in world coordinates. So it's a a precision problem in the fact that with where they are in the world, bring just kind of the small section, and so when you get down to that precision, it's not very accurate, so they jump around a little bit. So here it's got publications, what area of the site it was found at, more areas of the site, where it's currently held, and it's somewhat precise latitude and longitude of where it was. So, and you can do this for all these different artifacts. And like I say, some of them are symbolic of whether there were money or utensils, that sort of thing. And now let's bring up the Lidar data set, which I think over here. I think we're okay right now. Uh-oh. But we missed, it's the wrong Lidar data set for these artifacts. Let's see if we can, well, there's some overlap. Let me get rid of that. Well, not a lot of overlap. So let me turn that one off. Hopefully that, well, it may not take it out of memory, but I'm going to do this sparse one. Maybe that'll not be so bad. Nope, that's in the same place. There we go. All right, so this is a much more dense data set, and you can see that it corresponds with the artifacts that we were looking at. So let me see if I can fly there. And I don't know if I have this one. One of these data sets I don't have in Lidar Viewer because it was in a binary format. And the other two I did, so I don't know if this is the one I don't have. It probably is because it looks like it's a really great data set. I should probably do the nav. There we go. Yep, almost there. All right, obviously a beefier machine is required for this, the way it's currently rendered. And I believe they have a beefier machine at Koust, so that's probably why this is okay for them. So, I think we're underground a little bit. So anyway, I just wanted to give a kind of an overview of CalVR, and it's kind of I guess maybe a rising VR application. Although if it's too slow, then maybe it won't rise so much. But like most VR libraries, like I said, they kind of migrate. Their usage migrates with people as people migrate. So let me see what else I have to say about CalVR. All right. Oh yeah. So if you want to run it, you have to set all these environment variables before you run it, like the location of CalVR itself, so it can find the plugins. You have to tell it the actual config file you want, and then if you have different machines, different VR setups, you have different XML files for that. At the moment, I don't know whether they allow you to sort of include other XML files, which I've asked them. I haven't got a response yet. Because since the plugins are merged with the hardware, it's contained. So I would hope that they actually do have that mechanism. All right, and then just to run the program. All right, so it's on GitHub, so you can actually just download it, and it comes as two components. There's the application itself, and then a suite of plugins. They do have some documentation, although for me, the first time I got it configured, I had to Skype with the guys at Cal IT in order to figure out how to do it. So so the documentation is not fully adequate. One of the weird things they do is, and kind of that annoys me, is most most of the VR libraries, they pick an origin on the screen, like usually the lower left corner, and then they either pick an axis for the horizontal, an axis for the vertical, or a point that indicates the axis for the horizontal, a point that indicates the axis for the vertical. What they do is the origin is the center of each screen, and then you use 3 Euler angles to say how that screen is oriented around that, which is, in my mind, archaic. But
The origin, and then it does 2 vectors. So
right, that's what.
and then it
Right,
does vectors.
yeah, I think that's a much more reasonable way to do it. All right, and that's it for CalVR, and then I just have a few closing slides on a different slide set. Any other questions on CalVR while I'm doing this? It does, yes. So it comes up with a desktop mode, and as you can see, you can interface with these things with the mouse. The mouse is just another pointer into the world. All right. Aha, very good.
Is it bouncing between the 2 eyes or something?
No, it's just if the head moves even the very smallest amount, I mean the precision just can't handle it. Wrong mouse.